Okay, let's jump right in. Picture this. You've stumbled into this incredible, almost magical juice bar. There's this huge table laid out with all kinds of amazing fruit, and you get to pick any three you want to make your own special juice. The big question is, how many different drinks could you actually create? Believe it or not, we're going to figure that out right now.
So, this is the delicious little puzzle we're tackling. You've got 10 different fruits to choose from. All you have to do is pick 3. I mean, how hard can that be, right? Well, you might be surprised at just how many choices you actually have.
Yep, so we're talking apples, bananas, cherries, pears, you get the idea. 10 fruits in total. And our mission is to find out how many unique 3 fruit juices we can whip up. That's the core question.
Okay, so here's where things get interesting. To get to the right answer, we're actually going to start by getting the wrong answer first. I know, it sounds a little backward, but stick with me here. It's the secret to solving the whole puzzle. We're going to start with this concept called permutations. Right, so first up, permutations. Now, in the world of permutations, order is everything. It's like your phone passcode, right? 1, 2, 3, 4 is completely different from 4, 3, 2, 1. So for a little bit, we're going to pretend the order of our fruits matters a whole lot.
All right, let's zoom in a bit. Forget all 10 fruits for a moment. Let's just pretend we've already picked our 3. We've got an apple, a banana, and a cherry. We're just going to use these 3 to really get a handle on how this whole permutation thing works.
So the question is, if the order really truly matters, how many different ways can you line up these 3 fruits? Like, how many unique lists can you make? Think about it for a sec. Let's walk through it. Okay, so for that first spot in our list, well, you've got 3 choices, right? Apple, banana, or cherry. Let's say you pick the apple. Now for the second spot, how many choices are left? Just 2, the banana and the cherry. And once you've picked one of those, for the very last spot, you're left with only 1 choice. And that little calculation we just did, 3 times 2 times 1, well, math has a pretty cool name for that. It's called a factorial, and we write it with an exclamation point. So whenever you see 3 exclamation point, it's just a shorthand way of saying 3 times 2 times 1.
And what does that equal? Well, 3 times 2 times 1 is 6. Simple as that. So there are 6 different ways to order those 3 fruits. Apple, banana, cherry is 1, but then you've got apple, cherry, banana, banana, apple, cherry. You see? 6 totally different lists if order is all that matters.
Okay, so we've got the basic idea down. Now, let's go back to our big problem with all 10 fruits. But for now, we're going to keep those order matters glasses on. We're about to make a big overcount, and that's exactly what we want to do.
So yeah, just play along for a minute. Let's pretend that putting the apple in first, then the banana, then the cherry, makes a completely different juice than if you put the cherry in first. We both know that's not true in real life, but this little game is the key to everything.
We're just going to do the exact same thing we did with 3 fruits, but now with 10. So for our first pick, we have 10 choices, right? Easy. But for the second fruit, we've already used 1, so now we only have 9 choices left. And for that third and final fruit, we're down to 8 choices. So the total number of ordered recipes is 10 times 9 times 8.
And when you multiply that out, you get 720. Whoa, that's a huge number. 720 different ordered juices. But does that feel right to you? It feels way too big, doesn't it? And you'd be right. It is too big, because we've been counting in a way that just doesn't make sense for juice.
And this is the big aha moment. This is where we fix our mistake. Because when you're making a juice, does it really matter what order you toss the fruit into the blender? No way! An apple banana cherry juice is the exact same drink as a cherry banana apple juice. So that order matters thing we were doing, it made us count everything way too many times. Now it's time to correct that.
So this chart here is basically our treasure map. It shows us how to get from that giant number, 720, those ordered triples, all the way down to the real answer. And it all comes down to one simple little step. This is how we find the true number of combinations.
But wait a second. The chart says we need to divide by 6. Why 6? Where does that number even come from? Well, it takes us right back to our first little example with the apple, banana, and cherry.
Just look at this. On the left, in permutation land, every single one of those is a different thing. But over on the right, in the real world of juice, all 6 of those different lists, they all just collapse into one single juice. It's the same drink. That's the whole point.
So this is it, the key takeaway. When we got that big number, 720, we weren't just counting each unique juice once.
We counted every single juice a total of 6 times. Once for every possible way we could have ordered its ingredients. So, to fix our mistake, we just have to divide out all those extra copies.
And that means the math is actually super simple. You take that big wrong number, 720, and you just divide it by 6 to get rid of all the duplicates we accidentally created.
And what do you get? Boom, 120. That's our answer. 720 divided by 6 is 120. So from those 10 fruits, you can make exactly 120 different, unique 3-fruit juices. That sounds a lot more reasonable, doesn't it? But hey, that's still a ton of choices.
So what's so cool about this is that what we just did for our juice problem, it's not just a one-off trick. It's actually a super powerful tool that works for counting anything where the order doesn't matter.
And this right here, this is the formula. It's kind of like the master key for any combination problem. It might look a little intimidating, but it's doing exactly what we just did. We call it N choose M. The N is just the total number of things you have to choose from. For us, that was 10 fruits. And the M is how many you're picking. For us, that was 3. You can use this for picking lottery numbers, forming a committee, anything where the final group is all that counts.
All right, before we finish up, let's just do a quick little reality check. Let's see if this big fancy formula actually makes sense in a super simple situation.
Okay, new scenario. Let's say you only have 3 fruits, apple, banana, cherry, and the recipe calls for a 3-fruit juice. How many choices do you have? Just 1, right? You have to use all 3 of them. Common sense tells us the answer is 1. And guess what? If you plug those numbers into the formula, C33, it spits out the number 1. The math totally backs up what we already know.
So there you have it. We started with a fun little question about making juice, and we ended up with this really powerful way of looking at the world and counting choices. And seriously, this idea is everywhere, from picking pizza toppings to building a fantasy football team. Now that you know this little secret about counting, I wonder, what choices in your own life are you going to see a little differently?